Hello, this is the fourth lab for Physics 2211, Oscillations. It's a brief introduction to the purpose of this lab. The goal was to model the motion of springs through a lens of force and energy. As seen on the right, this is our setup, along with the practical applications of conservation of energy and how experimentation is rarely perfect, and as seen in this lab, sometimes what physics principles are slightly off due to things that we may not be accounting for. As for the physics principles, the main ones are the momentum principle and the conservation of energy. Momentum principle simply being choosing a system and a surroundings, and then finding the forces and calculating the values of the forces over an iterative amount of time, and then checking reasonableness. While conservation of energy states that the change in energy is zero and the sum of change of energies is zero, and if you can find what energies and what change in energies are being acted on the ball or the system, then you can solve for unknowns that way. Important equations: position change equation, velocity change equation, force of gravity, net force, spring force, conservation of energy, kinetic energy, gravitational potential energy, and spring potential energy. As for the system itself, the system contains the ball and the spring, while the surrounding contains the earth. The two forces acting are the spring force, which is negative L hat direction, and the gravity force, which is negative Y hat direction. As for the time, delta T, 0.017 is the time between frames on the camera, and 1/18 was a multiple that was it is a constant use to align the data calculated with the data experimented. As for video of motion, as you can see from this video, the spring bounces back and forth. The Y seems very jittery, but that's just because of the way that the phases line up left and right. However, it actually does end up being jittery, but it is different than what it looks like in the video. The X axis was very smooth, very simple pendulum, while the Y-axis was sort of more out of phase. We'll talk about why this might be later. As for the code, this is the initial setup. This is a picture of the spring setup, and this is a picture of the changes in energy. We'll talk about that later. Gravitational force near Earth's surface, G, that's a constant. Spring constant, that was calculated by measuring the resting length after different weights were added onto the spring, and then calculating both spring constant and relaxed length of spring. As for the position of L, the vector, we used the first data point in tracker with the origin set at the base of the spring, L hat, and then S is the difference, the displacement. K, kinetic energy, 1/2 mv squared, UG, mgh, spring potential energy, 1/2 ks squared, and then sum of the energies is the sum of those three variables. As for the changing code, this is in the calculation loop. Define initials, force of gravity, mg negative y hat, force of spring, negative kss l hat, net force, sum of both of those, velocity update, position update, spring update, same energy equations, add them all together, sum it up, then you get your beautiful graphs. So as for results, change in energy versus time, delta E is 0. That means that energy is conserved. As for X position, they match up really well, which means that our model was a pretty good detail of the experiment. However, in the Y-axis, not so much. Potential Z effects, there's a Z-axis that is not necessarily being accounted for because I may not have released the spring perfectly in plane with the camera. As for discussion, is the energy principle satisfied? Yes, delta E is 0. There's a little, it's not a perfectly straight line if you look really close at it, but that's besides the point. As for the period of the X and Y components, the X component period is about 1.4 seconds, while the Y component period is about 1.1 seconds. I believe the main difference of this is that the X force is greater than the Y force. The X force contains just the X component of spring force, while the Y force has the Y component of spring force being slightly canceled out by the negative gravity. So yeah, thank you.